Okay, good morning good evening once again. So let's start. The class rep told me that we should be solving this past question tonight. And I think it's the agreement of everybody that we should start solving this past question. Am I right, please? I need answer to
Yes,
that.
sir.
Yes,
Yes,
sir.
sir.
Okay, good, good. Okay, so I hope we all have this past question with us, or this practice question with us. Do we have it?
Yes, we have it. Yes.
Okay. So I'm going to start from number one. And then aside that, I'll be solving it for you. Then I will be telling you the class of statistic that it belongs to, so that anytime you are having a particular question, you should be able to know that this particular question belongs to descriptive statistics. This particular question belongs to inferential statistics. This particular question belongs to probability. Then what type of descriptive statistics? Is it the mean, median, mode, or the graphical part of descriptive statistics? What part of our inferential statistics? Is it the estimation or testing of hypothesis? So those are the things that we're going to be looking at tonight according to your class rep and the entire class. Okay, so we start with number one. Excuse me, please. The number one, the following are weights of students in kg, kilograms. So we have this data set. And then the question is construct a frequency distribution table of 6 classes. The second question is determine the mean and the median of the weight. The number 6 question is calculate the standard deviation and the standard error of the weight. Then what is your conclusion about the distribution based on B? Okay, although I got this particular schedule late, because the class rep messaged me around, is it 5 or around 4 that we'll be solving past questions. So I've not even laid my hand on it, solving it. But looking at it, we can keep solving it together, and then we are going to be we'll be arriving at the same answer. So look at this number one. The first thing that you are going to see here is that they ask you to calculate the construct a frequency distribution, the mean, median, mean median of the weight. So this one is telling you that this particular number one question belong to the class of what we call descriptive statistics. Is belong to the class of what we call what? Descriptive statistics. Now, in our descriptive statistics class, that was our first class. We talked about the group and on-group data. So this particular data that you are seeing here is on group data. So you are expected to group it. This particular data that you are seeing in this question number one is on group data, but you are expected to do what? To group it. And they've given, that was the first question A. The question A is construct a frequency distribution table of 6 classes. So that means that they want you to have just 6 classes for all this data set. The 6 that you are seeing here is not the interval. Please note that. It's not what? It's not the interval. They just want you to create what? To create 6 what? 6 classes. So the first thing that you are going to do here is that you will first of all identify the minimum value. Then once you identify the minimum value, then you can also, the next thing is to identify the what? The maximum value. So you have to know the minimum and then the maximum. This one, the minimum will help you where to start from, and then the maximum will help you where you are going to stop. So it is very, very important to look at what? To look at that. So looking at this data, what is the minimum? So because tonight's class is practical, we're going to be solving it as I'm saying it. So what is the minimum from that class that we are seeing?
Minimum is
60
60.
kg.
The minimum is 60 kg.
62 is there.
60 kg.
62. 60.
Please look at that question very well, because the ability to
Minimum
look
is
at
62.
question very well will help you in solving it. So the minimum here is 60. The minimum is 60. Then what is our maximum?
77.
77. 77.
77. That is our what? That is our maximum. Good. So now we have the minimum to be what? to be 60, and then the maximum to be what? To be 77. Now, how do you now going to what? Distribute this data that is going to fit to just 6 classes? That means that it must not be less than 6. It must not be greater than 6. Are we together now? It must not be what? It must not be less than 6, and it must not be greater than 6. So now, if I use 3 interval, if I use what? 3 interval. So I don't know the reason why you are not given the interval. I don't know the reason why. So it's the reason is best known to your lecturer. So let us use 3 interval. If you are using 3 interval, so it's going to be from 60 to what? To 62.
62.
So it's going to be from to 62. So be forming your interval like that. So the first column is going to be what we call the class interval. Class interval. So the class interval, the number 1 is going to be 60 to 62. The next one is going to be what? 63
to 65.
65. Then we're going to have 66 to 68. The next one is going to be what?
69 to 71.
Then we have 72 to 74.
74.
Then we have 75 to 77.
77.
So by the time you count it, this class interval that we have, it's covered for our minimum. It's also covered for our maximum. It's covered for our what? Our minimum. It's covered for our maximum. That's number 1. Then number 2 is that we are able to distribute this into 6 classes. If you count it, 1, 2, 3, 4, 5, 6. We have what? 6 what? 6 classes, which we've satisfied the classes. So now we want to construct the frequency. We want to construct the frequency.
Frequency is fx, Abby.
So we have what? 6 classes now. So
Please,
let us
excuse me,
go
sir.
back.
I'm very sorry to interrupt. I didn't get the grouping, please. I'm sorry to interrupt. I didn't get the grouping.
Okay.
Thank you.
Look at the question. So let's move our mic. Look at the question.
Sorry, sir. I can't even see where you are solving it. I can't see it there. I can't see it on my own phone.
I'm stopping inside my notes. That's what I'm saying. I told you that you should also be writing as I'm saying it, because the class rep told me like around 5 p.m. that we're going to be solving the past question. So now, if I have to solve it and type it, I can't finish it today. Did you get that, please? Because if I'm solving it, if I have the solved one, I have to type it so that I can project it for you. So about the time frame is too short. Do you get it, please? So as I'm saying it, as I'm saying it, you'll be writing it. Be checking your network.
Sorry for coming. I mean, for cutting short. Please, in that case, please, can we start the solution again, please, sir?
Can you see my screen?
No.
I can see the.
Please check your network. Once you cannot see my screen, check your network.
We can see your screen. Continue.
Yeah. So if you cannot see my screen, if you can hear my voice, that is better.
Yes. Okay.
If you can hear my voice, that is better. So let's start again. But I still have one little problem here, is that those people that are not joining now, they will still be asking the same question. They will still be asking the same question, and we are not going to be moving like that. So what should we do? Should we still give them time for them to come in, or we should continue?
I think you should allow them come in, sir, so that we move at.
Let's drop it on the group that you are solving questions so that they should not draw us back again. Time is going.
So should we continue or we should wait?
Sir, please, let's give them little time.
Let's wait for us to send the
Let's continue. Since we are going to have a copy of it afterwards. Since we are going to have a copy of it later, let's continue.
Sir, please, let's hold on for them, please, so that we all move together.
So how many minutes should we take to wait for them?
Hello, sir. Hello, sir. Hello. Hello. Hello, sir.
I'm with you. I'm asking that how many
Yes, sir.
minutes should we take to wait for
Uh,
them?
I just want to clarify something before they arrive. While we wait for them, I just want to ask about something. How you quickly jump at using 60 to 62 at interval. You quickly jump into picking 60 to 62. Is it that easy? How did you arrive at that quickly like that?
It's because
Sir?
the question asked me that I need the interval of what? The interval of what? Or I need 6
See,
classes.
network. I can't hear you again.
Hello, sir.
Can't hear again.
Hello, sir. Hello, sir.
Ma, I can
Hello,
hear you.
hello, the class. Please, I'm just taking an excuse. I just want to address our people. Please, who are those that we are waiting for? Who are they? Hello, somebody in the class. Who are they that we are waiting for?
Well, I'm not
That
sure
is it.
who we are
They
waiting
are
for.
trying to repeat what we
Did
are
they
doing.
take
I think the
permission
thing is
from the,
being recorded.
excuse me, did they take
I don't
permission
know.
from
Let's
the
not wait for anybody.
lecturer
Eh?
or from the rep?
Let's continue. I will have a copy of it.
Hello, sir. The lecturer, sir.
I'm
The
with you.
lecturer, sir.
I'm waiting. I'm waiting.
Thank
I'm
you
with
very
you.
much. Please, let's move. They will meet us on it. And if at all, at least you are recording it, they will still have that one to make use of. We cannot continue to be waiting. Time is going. This is 16 minutes after 8. Thank you very much, sir.
All right, thank you so much. So let me pick the question again, and let us pick our pen and paper, and then let's start writing. Now, I'll also try as much as possible to write on this question here. So let's start. Now, if you look at the first question that we're having here, we have a data that is not what, that is not group, that they want us to group that data set. So, but they did not give us the interval that we should use. But we are given what? That we should put it in 6 classes. So they want this data to be in how many classes? Just 6. Now, the first thing is you are going to find the minimum. And then the minimum here is what? Is 60. The minimum is 60. And then the maximum is what? The maximum is 77. Am I right? So now, the next thing that you're going to do, because I pick 3, because I know from here I'm going to be using 3. But let me tell you how I got my 3. Now, let us mute our mic. I'm still hearing voice. So from here, 77 minus 60. What do you have? 77 minus 60. We're going to have 17, right?
17.
Now, 17 divided by the number of classes that you want, divided by 6. What do you have? You have 2.8. Approximate it to the nearest whole number. You have what? You have 3. Did you get that?
Yes.
Thank you.
Good.
Clear
Yes,
now.
sir.
Is that one clear now?
Yes, sir.
Okay, good. Can we move
No,
on
sir.
now?
No, sir.
It's not clear, sir.
Okay, which one is not clear? Which one is not clear? Okay, let's move on. If you don't answer me, so let's continue, please.
I think the lecturer has muted himself.
Sorry, do we have class rep here?
Yes, I'm here, sir.
Please, I want you to address the class, please, so that we can move smoothly.
Please,
Let
let
them,
us all
maybe you
meet
should put it on that group. Let everybody join now. Let everybody join now. Let
Okay.
everybody join now. So please, let me assume that that 20 minutes is not exist that we've used. So please let everybody join now. So I'm going to stop by 10
Hello, sir.
or 10:30.
Hello, sir.
I'm with you, ma.
And more to the point, sir, the rep too. Let anybody, if you have any question concerning anything that we might be, working towards, or whatever calculation we may be doing, please take your pen, put your question somewhere, so that at the end of that, we can now ask questions so that we can move quickly. And we have 15 good questions. And treating it is not the only thing. After the treatment given to it, the workings and everything, we need to still master everything, because you don't know which one is coming. So me, I don't want to play. I don't want to joke with this. Please write down your questions, so at the end of everything, you have the time to ask the lecturer. Thank you. Thank you, sir. Thank you, the rep.
All right, let's move on now. So I'm starting again. So take your pen and paper. So let's start. Now, the first question is, the following are weight of students in kg. So they have the weights. Maybe they've used the weight balance or the any form of machine that they use to measure the weight. So they have this weight of what, of students. Now, these weights are data that they've gotten. So, and this particular data that you are seeing here, it is called ungrouped data because it is not grouped. So that is number one. Now, the number two is this. They now ask us to what, to group the data, but the interval that we want to use in grouping the data is not given. Is not what? It is not given. But the only thing that we know here is that you are given the what, the classes that they want you to have, that you must not have more than 6 classes. You must not have more than 6 classes. Now, how do you get the interval to do or to group this data set? The first thing that you have to look for is find the minimum, the lowest. Let me be using that language. The lowest value here that you have. The lowest here is 60. And then the what? The highest that you have is 77. Now, find the difference between the two. What did I mean by the difference? The difference is just 77. 77 minus what? Minus 60. So 77 minus what? Minus 60. Then divided by 6. So that one will give you the interval that you are going to use. So at the end of that, you are going to have 2.8. So by the time you approximate it to the nearest whole number, that is, you are going to round this one up to 1 because it's what is greater than 4. So any value that is less than 5, that is 4 downward, you round it down. We count it as 0. But any value from 5 upward, we round it as 1. So it is not that 1 that you are going to add to this. Once you add that 1 to this, your answer is going to be what? It's going to be 3. So that means that you are using a word, the 3 interval. That is how you are going to get your interval. Assuming that the question asks you that you should form 8 classes. So that means that you are going to divide it by 8. If the question asks you that you should form 10 classes, that means that you are going to divide it by 10. So the maximum minus the minimum divided by the number of classes is going to give you what we call the interval. I think I'm clear with that. So from there now, you can now do what? You can now group your data set. So now, how do we group our data sets now? So let's move down to that place. So from now, we are going to what? We are going to start from 60. So since we know that our minimum is what? Our minimum is 60, and then the maximum is 77. So we are starting with 60. So the class interval now, class interval, which is CI, we are starting from what? So it's going to be from 60 to 62. From 60 to 62.
63.
So 62, because 60 is included. Count your hand. 60, 61, 62. 60, 61, 62. That is 3. So the next one is going to be 60 to 65.
65.
Yes. So because if you count it, 63, 64, 65. So the next one is going to be what, please?
66 to 68.
66 to 68.
Eight.
In your table now, please compute the remaining one, and then you give me the final interval. Compute the remaining one. Please make sure you are working it. Make sure you are doing something.
The final interval is 75 to 77.
What is the last interval?
75 to 78.
75 to 77. Good. I'm happy that we are getting it. Yes, good, great. So now the next thing that we're going to do now, after we've gotten the what? Please let's mute our mic. So after we've gotten our class interval, is what we call the what? The tally. Since we are using what? We are going to have a tally. Please mute your mic. Please mute your mic. So the reason why we are using tally is because it is on group data that we want to group. So what do they mean by the tally? I'm going to show us now. Now, from 60 to 62, count how many numbers fall within that range. How many data fall within that range? Can you check that for me, please? And give me the answer. Two, right? So now, before you now have the frequency of 2, please complete this one. This is tally. Then you have F here, which is the frequency. So before you write the 2 here, we are going to have 2 strokes of line. That is what we call the tally. Then you write your 2 here. Did you get that aspect, please?
Yes, sir.
Okay, good.
Yes, sir.
So now, good. So now we are through with that. The next one is we are moving to what? 63 to 65. So how many numbers do we have within 63 to 65?
5.
8.
5.
8. 8.
8 is 8.
Please
8.
check it again.
5.
It's 5.
8.
It's 8.
It's 5.
Okay, 1 minute. Let everybody check it again. 1 minute. Let everybody check it again.
We have 6, sir. 6.
It is 8.
It is 8. 8.
It's 5, sir.
Bùlẹ̀ wá ti rí méjì tó kù.
5.
It's 5.
8
63 to
8
65.
It's 8, oh, 8.
5.
So let's work it together. Please, let's mute our mic now.
It is 5. 63 to 65 is 5.
I got 8.
It's 8.
I got 8.
Please mute our mic. Let us do it from here. Let's mute our mic now.
I
Please,
got
let's
8.
mute our mic now. At this point, after tonight's class, please, we should have the same thing. We should have what? The same thing. So let's look at it together. 63 to 65. Let me clean this so that 63 to 65. This is number 1. 63 to 65. 63. This is 2. 3.
You have missed 64, sir.
You have omitted 64, sir.
I've
At
done
the
that.
first,
I've done that. I've done that. Okay. 63 to 65. Another one here. 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 63 to 65. I think we're okay, right? So 1, 2, 3, 4, 5,
Sir,
6,
there's
7,
we have
another
8.
one
it.
beside 64, sir. 62.
You can't pick
Rara,
62.
62 is the first one.
62 is the first one.
We-
The first one is 62. Please, let's mute our mic. Let's mute our mic. That means that you are not following us. The first one is we are using the interval of 3. From 60 to 62, that is 3. That's first one. The next one is from 63 to 65. So if you count this now, 1, 2, 3, 4, 5, 6, 7, 8. So we're having 8 for 63 to 65. Do we understand that, please?
Yes, sir. Yes,
Yes,
Okay,
sir.
the
sir.
next
It's
one.
correct.
So the next one is 66 to 68. By now, we should get the same answer now. Can we do that? Can we do that? Okay, 19. Let's confirm
18.
from 2 or 3.
I 18.
19.
Please, anytime you are picking a question like this, you are going to zero your mind from other question if you want to get it. And then you will focus all the attention to it. You will not think of any other thing again except for that particular question. So if you are solving this question at home, you will not think of anything again if you want to get it except for this question. So please, can we go over it again, please? We must have the same answer.
20.
is 19.
19.
19, sir.
Let's move on.
19.
It's 19. It's 19. So the next one, 69 to 71. For those people that did not get 19, please go over it again. It's 19 that you are going to have. The next one, please. 69 to 71. What do you have?
21.
Let another person confirm. I just want two answers, then we move on.
Yes, 21.
Okay, good. The next one is 72 to 74. What do you get?
9.
9. 9.
9.
Okay, 9. Correct. So the next one, 75 to 77. What do you get?
5.
5.
Okay, good.
5.
So we have all our data set, but if you count your interval now, sorry, if you count your class, how many class do you have there?
6.
6. So that means that by solving that thing that you just created now, you solve question A. That is what they ask you to do. That is what they do. What they ask you to do. Good. Now, the question B part, they ask you to find the mean and the median. They ask you to find the mean and what? And the median. Remember that from our descriptive statistics, I told us that if you want to find the mean for group data, it is what? Summation what? Summation fx. Summation fx over summation f. Not s, so it's f.
Summation F. Frequency.
Okay, summation f over summation f. So we've gotten our f. That is our frequency. So add all the frequency together. What is our answer for that?
64.
64.
64.
Okay, please let's mute our mic. It's 64. Good. Now, how do you get x? X is the middle value of your class interval. So you are going to create another column called x. You are going to create another column called what? Called x. And then please, you cannot run away from this type of question because they just have to bring one question from descriptive statistics. And who knows, they may bring this thing out again. So now, how do you get the what? The middle class, the x? The first one for the first class is going to be 60 plus 62 divided by 2. 60 plus what? 60 plus 62 divided by 2. So by the time you do that, what do you have?
61.
So for the first
61.
x, you are going to have 61. So now the next one is what? 63 plus 65 divided by 2. What do you have? You are going to have 64.
64.
Okay, 64. Now, I told us something when we were treating
67, 70, 73, 76.
So I told us something that when we are treating our descriptive statistics, that once you have your class interval correctly, so that means that just add it to the remaining one. So please, can you produce me the x's now? The first one is what? 61.
61.
The second one is what?
64.
Okay.
67.
64.
67. What is the last one? What is the last one?
70.
76.
76.
Okay, good, great. We are getting it. Good. So after that, you've gotten your x. The next thing that you have to create is what we call the fx. The f what? The fx. How do you get your fx? So that means that the frequency of the first one, which is 2, times the first x, which is 61.
Okay, times.
It's not plus, so it's times. So this one will give you the first one, the first
Okay,
fx.
sir.
So the next one is going to be, the frequency is 8. 8 times the x, which is 63.
64.
So this one is going to give you the next one. Then you continue like that. Can you do that for me? and get the answer. So once you have all this answer, add
Sir,
them
we don't
together.
have 63. Excuse me, sir.
What
The
do you have?
second one is
64.
64, sir.
64, yes, 64, good.
Yes.
What? All the fx, which is called summation fx. Please
Yes.
put your hand in on paper and you start working now. So this is practical.
Yeah,
So
summation f is 4.
please mute your mic and start working.
Summation fx is equal to 4,414.
Okay, 4,414, right?
Yes, sir.
Okay, good. Let us
Yes,
confirm from
sir.
one person
And the
then we
mean
move on.
the mean
Is it
is
correct?
68.97. Yes,
Okay,
yes, sir.
divided by 64, we have your mean.
64.
I want one person to confirm again.
68.97.
I want another person to confirm again.
68.97. That's the mean.
68.97. Good.
97.
Good. Good. 68.97. Please, another person should confirm again. Is it the same answer?
Yes, sir.
Okay. Now we are, so that means that you've solved for the mean. Now it's now remain the median. So the knowledge of what we've taught in descriptive statistics will now come in now. Remember that this is a group data. And then there is a formula for getting the median for a group data. If you recall, we have L plus open bracket N over 2 minus cumulative
We are not seeing your
frequency. You are not seeing my screen.
Zoom it,
Yes.
please.
Yes, sir.
Minus cumulative frequency before the median class, then divided by the frequency of the median class. We've treated this before. We've treated this. That's our first class. So multiply by C. So you should go and revise your first class. So by the time we want to find the L is called lower class boundary of the median class. And I told us how we can get our median class. The next thing that we are going to do is to calculate the cumulative frequency. Calculate what? The cumulative frequency. How do you get our cumulative frequency? If you remember,
minus 0.5.
That's not cumulative frequency.
No.
That is class band. To get
Cumulative frequency is
we are going
2
to start
plus 8.
with 2. The next one is going to be.
Let him talk, please. Please.
Let's hear the teacher.
Abi.
The first one is you pick your first frequency. The first frequency is 2. Now, that 2, you will add it to the next frequency. The next frequency is 8. By the time you add 2 plus 8, you are going to have 10. Yeah. That 10, add it to the next frequency. The next frequency is what? It's 19. So 10 plus 19 is going to give you 29. This is how you are going to be doing until you get the last value. Your last value must give you 64. Can you confirm that for me?
Yes, sir.
All right.
That's what we have.
Okay, good. That is
yes,
what we call
sir.
the cumulative frequency. Did you get that, please?
Yes,
Yes,
sir.
No, sir.
Excuse me, sir.
Okay. I'm with you. Excuse me, I'm with you.
Okay, sir. Sir, sorry, I just so that we can all be on the same page. Please, sir, for the frequency they got under 72 to 74 and 75 to 77, can someone just tell us to save us the
72
time
to
of
74 is 9. 75 to 77 is 5.
69 to 71?
21.
All right,
21.
thank you, sir.
Okay. So please, if you have any question on this, please go and revise the first class.
Yes.
I'm listening to your question.
Okay, sir.
We've treated everything.
I just want you to iterate me with mean. Yes, we know mean. How do we get mean of this question now?
Summation fx over summation f. So by the time we do this,
Hello, sir.
I'm with you.
Yes, sir. Summation fx all over summation f is for grouped data. But the data they gave us here is not grouped.
That is why that's the first question. They asked you to form the 6 classes, so they want you to group it.
Okay.
Did you get that?
After we have grouped it, it has become grouped.
It has become group, yes.
Okay. Thank you, sir.
Okay. Now, so by doing that, you are going to go back to that first class. I think I've shared this slide. You go back to that first class. You are going to calculate the median for me because of our time. You follow that procedure that I use in getting my own. You apply the procedure here. Since you have grouped your data, you have your class interval now, you have your frequency now, and then you have your X now. Follow that procedure in getting mean. So you are going to get me that mean and send it to the group tonight. Please do that tonight. So that is for that. That is for the median. Now, the next one is they ask you to calculate the standard deviation. Remember that in our first class, we also talked about standard deviation, and I show you how you can get your standard deviation, and I gave you 4 different formulae. So you are going to apply that too in getting your standard deviation for me. The only one that I'm going to be solving here tonight is the standard error, because we didn't get to standard error in our first class. For the standard deviation, we've solved that. We've talked about that in first class. The mean, we've talked about that in first class. The median, we've talked about that in first class. So that means that you're just going to revise the first class. Now, the standard error.
Excuse me, sir. We did not standard deviation. We stop at variance, sir.
We stop at variance.
In fact, that's the formula.
Okay. Please, one house. Please, one house. One house. You said we did not use it. The
we did not even use it to solve any problem. Just stop at the formula.
But I share you the slide, and I've solved it there. I used one formula to solve that particular problem. So use that the same formula to solve this particular question. Assuming that I've gotten this question earlier, I will have typed it and put the solution here. Did you get what I'm trying to say? But if we are going by this, we will not solve this. We will just solve one question for the whole 2 hours. And that one will not really help the class.
Sir, maybe you don't the answer for us later so that we can use it to confirm, sir, whether we got it or not.
Okay, I'm going to drop the answer later. So
okay, sir,
now, when you calculate your variance, let me start from the variance. I gave the formula for variance. So when you calculate your variance, the standard deviation, SD is the standard deviation, is equals to the square root of your variance. So once you get your variance, just take the square root. You have your standard deviation. Standard deviation is the square root of the variance. Do we get that one, please? So,
yes, sir.
Yes.
Okay. Now, after you've gotten your standard deviation, the next thing is what we call the standard error. The standard error. And then the formula for the standard error is not hard at all. All these things not hard. Just for you to be getting, if you get one, it is that one that you're going to use to solve the second one. The standard error is equals to the standard deviation over square root of your sample size, square root of n. This is the formula for standard error. So in our case, in our own case, our n is the total sample that we have, which is 64. So that means that After you've gotten your standard deviation, you are going to have, let's say for instance now, I've calculated my own and I have my standard deviation to be 6.7. I'm just using this as an example. Then to get the standard error, is going to be divided by square root of 64. I'm going to have the square root of 64. So by the time you do this, you are going to have what we call the standard error. So the standard error is the what? Is the standard deviation over square root of n. Are we clear with that?
No, sir.
Which one you did not get, smart?
You said standard deviation is the square root of n.
Standard deviation is
I mean,
the
you
square
said
root of
standard
variance.
error. No, you said
Standard
standard
deviation
error
is
is
the
the
square
square.
root of, let me take it again. Standard deviation is the square root of standard, is the square root of variance. The standard error is equal to standard deviation all over square root of n.
Continue.
Where n is your sample size. So ask your question now.
Okay. Is that n that I don't know where you get the n? So n is the sample size. All right. Thank you.
Can someone tell us how we got our n?
I've gotten it now. I didn't know the n you are referring to before. So I've gotten the n.
From our table.
That's
Summation
the
of frequency.
Okay. So that is that.
I've got.
So by the time you do that, you are going to have what we call the standard error. So that means you've solved the whole question C like that. Now the question D, what is your conclusion about?
Sorry, sir. Before you continue, sir. Sorry, sir. What is the formula for variance?
The formula for variance was given in the last class, which is summation f into x minus x bar square all over summation f if your n is greater than 30, or you have summation f into x minus x bar square all over summation f minus 1 if your sample size is less than 30, or you can use summation fx squared minus summation f all squared divided by n all over summation f if your n is greater than 30. I gave 4 of this formula in our first class. Go and revise that slide. It's there. So you pick anyone, you use it, and you have your answer. Any question again?
Please, I'll come again, no?
We will not progress. Please, let's move forward. Go and check your notes later.
The slide, I sent it to class, so that means that you did not check it. I sent the slide, both the slide and then the recorded voice notes. I sent it to the class, so that means that you did not listen to it or check it. So the last one is, what is your conclusion about the distribution? Then in our first class too, I mentioned
your
this.
slide is not showing, sir. Your slide is no longer showing. Okay.
It's your network.
In our last class, I mentioned something that anytime your mean is equals to your median, anytime your mean is equal to the median, that means that that data is normally distributed. Note that it is very, very important. Anytime your value of the mean is equals to the value of the median, so that means that your data is normally distributed. But anytime your mean is greater than your median, please note that anytime your mean is greater than your median, that means that your data is right skewed. It is not normally distributed. Anytime your mean is greater than your median, that means that your data is right skewed. It is not normal. Anytime your mean is less than your median, anytime your mean is less than your median, that means that your data is left skewed. It is not normal. That is what they want you to explain in your question D. Do we get that, please?
Yes, sir.
Yes, sir. Same thing.
And if you do this question very well, your mean will equal to your
Not
mean.
see, sir, I'm not seeing your slide though.
Check your network.
Check your network.
It's
So
coming back.
it's your network. It's not from my own end here. It's your network. So
Network.
if you do it very well, if you do the calculation of median very well, your mean and median is equal. Your mean and your median is equal. So let's move to the question 2, please. So who is disturbing us? Okay. Now the question 2. Distinguish clearly between discrete and continuous variable. Discrete and continuous variable, we talked about this yesterday under probability. Although we are not, I thought we were going to continue with our probability today with continuous variable, but we did not. So the discrete are the count variable, are the count number. The variable that you can count, that take the variable that take on the finite number. Like for instance, 1, 2, 3, 4, 5. Those are the discrete variable. Now, the continuous variable are variable that can take up decimal. Like for instance, now a variable height, your height can take up the decimal. But like your variable age is a discrete because you can't have 23.4. No. Your age is discrete, but your height is continuous. Your weight also what is continuous. So the number of people in this class is what is discrete. But the cutoff mark of or let's say for instance that if I say the pass mark for this course is 75.5, so that means that the pass mark is continuous, not what, not discrete. Are we together now?
Sorry,
Yes, sir.
sir. I don't
Yes,
You said discrete is countable numbers like
Yes.
age.
Yes.
And you said height is not
Those one
discrete.
has
Is height not countable as
decimal.
well?
Because
It
your
has
height,
decimal.
you have decimal in your height. You have decimal in your
Okay.
weight. Did you get that, please?
Okay.
That's
All
the
right.
reason.
Yes, I'm getting it, sir.
Good. That's the reason. Now, the next one is qualitative and quantitative variable. A qualitative variable, what's it called? Text. Text variable. Categorical variable. What did I mean by categorical variable? Categorical variable are variable that you cannot perform any statistical you cannot perform any what's it called, any arithmetic on. What did I mean by arithmetic is that you cannot add them together. You cannot subtract one from one. Let's say for instance now your gender. Your gender is a qualitative. You cannot add your gender together. You can't say male plus female. Your blood group is categorical, is qualitative. You cannot add your blood group together. Now, under the qualitative, we have two types. Under the qualitative, we have two types. Number one is what we call the nominal variable. Number one is what we call the nominal variable. The nominal variable are the variable that is not with order. Or let me put it like this. Anytime you are having a binary number, the binary outcome, let's say for instance now the status of a test, someone carry out the test for the COVID-19, is either it is positive or negative. In that case, the variable of that COVID-19 test outcome, it is qualitative because it belongs to the group of categorical, which is nominal. Now, the other one that we have under categorical is what we call the ordinal. That one follow ordered. Let's say for instance now, if I want to rank, let's say I want to rank the position. Let's say, for instance, now those people that they got A, they got B, they got C, and they got what D. So that means that there is an order that they have to follow. You can't have A, then followed by C. No. It is after A, it's followed by B, followed by C, followed by D. So it's follow order. That is why it is called ordinal. You order it. But in the case of nominal, there is no order. Male can come first, female can come first. So that does not mean that because you are male, you are more superior to female, or because you are female, you are more superior to male. No, there is no order in nominal, but there is order in ordinal. Please, you have to take note of that. So the combination of the two is what we call the categorical variable. The combination of the nominal and then the combination of the ordinal is what we call the categorical variable. Now, the categorical variable and the text variable. Let's say, for instance, now I'm just asking you some question and you are telling me the answer. Let's say I'm just asking you, please, can you explain yourself to me in 20 seconds? My name is this, I live at this. So all those ones, they are text, they are string that you are right. So on that one, they also belong to what we call the qualitative variable or the qualitative data. Now, the other part is what we call the quantitative variable. A quantitative variable, number one, they are numeric variable. They are number. They are what? They are number. So under the quantitative variable, we also have what? We also have two types. Under this, we also have what? Two types. The first one is what we call the interval. Let's say, for instance, now the blood group, the blood pressure. The blood pressure average. So let's say someone that is normal, maybe it's between the range of, let's say, from 65. I'm just saying it as an example. So maybe it's from 65 to 80. So in that case, we have the interval. So anytime you are having the interval range of a number of numeric, it is a quantitative variable. It is a what? It is a quantitative variable. The other one that we also have is what we call the ratio. The ratio. Those are the ones that take decimal, like your height, like your weight. They are under what? The ratio. Where ratio is under what? Quantitative variable. So now, if they are asking you this type of question, after you have defined your quantitative variable, please give them one or two examples. I've cited like 2 or 3 examples now. After you've defined it, give them what? Example. Because if the definition, if the total mark here is 5, and they just split it to 2.5 each. Now, your definition can carry 1.5 mark, and your example will carry 1 mark. So if you are the type that you just define, you did not put example, that means that you are going to miss that 1 mark. It is very, very what? It is very, very important. Now, look at the next one, which is number C. The next one, differentiate between the outcome and the explanatory variable. The outcome and explanatory variable. Now, the outcome variable are your results that you have. Let's say, for instance, now, your weight depends on the food that you eat. So your weight is the outcome variable of the food that you are taking in. Now, another name for outcome variable is called dependent variable. Another name for outcome variable is called what? Dependent variable. Another name for outcome variable is called effect variable. Let's say, for instance, now you take in a paracetamol. The effect is that you want it to remove the headache. So immediately the headache is removed, that means that the paracetamol that you have taken it worked. So that means that the effect is also dependent on the paracetamol that you've taken. So the effect variable is also called the outcome variable. Another name for outcome variable is also called the response variable. So I've given you like 4 names for a particular what? A variable. So outcome variable is called response variable. Outcome variable is called effect variable. Outcome variable is called what? Dependent variable. Now, The other one is what we call the explanatory variable. Explanatory variable are the one that you take in. They are called independent variable. Explanatory variable are called what? Independent variable. Explanatory variable are also called treatment. Explanatory variable are also called what? Treatment. So I've given you like how many names now? Like 3 names for that. So in the course of you trying to find a relationship, is there any relationship between the food that I'm taking and then my height? So now in establish the relationship, the dependent variable is your what? Is your height, and then your independent variable is your food intake. So in that case, we normally use what we call a regression. So I hope we are going to get to that. So the next question is the interval and the ratio. The intervals and ratio scale for measurement. Now, under the interval, there is what we call true zero. There's what we call what? True zero. True zero simply means that anytime you are hearing the word true zero, it simply means that that zero is a real zero. That means that it is nothing. Anytime you are hearing the word this zero is a true zero, that means that it is nothing. But anytime you are hearing the word this zero is not true zero, that means that in zero in that sense, it does not mean that it is nothing. For instance, now, if you are having the temperature of 0 degrees Celsius, does that mean that there is no temperature? No. No. So that means that at that point, it is not a true zero. Temperature is not a true zero. Temperature value 0 degrees Celsius does not mean that you don't have temperature. So it's not the true zero. So now the interval contains what we call not true zero. It contains what? Not true zero. So if I'm giving you the interval of my temperature, that the temperature of that body is between 0 to 5, that does not mean that 0 temperature is nothing. So that means that the 0 that we're having in the interval range, it is what? It is not a true zero. So interval contain not what? True zero. So the interval is what? Is the range of the value that you have within what? Within the interval, I'm sorry, within the minimum and the maximum. So now, if I say I need the height of the student from what? From the let's say, don't let me use height. I need their age, like the one that we just did now. The weight, they've approximated the weight to the nearest whole number. So that is why we can have the weight from what? From 60 to 62. So in that case, we have the interval. In that case, we have what? We have the what? The interval. I just want you to understand the concept of this. You can bring out your own definition once you understand the concept. You don't need to cram anything once you understand the basis and then the concept. Now, the other part is the ratio. Ratio contains true zero. Anytime you are talking about the ratio, the 0 that you are seeing there is the normal 0. If I say your height is your weight is 4.0, sorry, your weight is 40.0 kg. So that means that 0 at that back is nothing. So that means that your weight is 40. So anytime you are hearing the word ratio contains the digits, the decimal. Then you can do what? You can have a true 0 in ratio. Now, if you are the type that you are familiar with the software called SPSS, Statistical Package for Social Sciences. In SPSS, they combine both the ratio and interval together and they call it scale. So in scale, you can have both the interval and then the ratio, because they can ask you to what? To define scale, to tell us about scale. Scale contain both the what? Both the interval and then what? And then the ratio. Now, let's move to the next one. I hope you are hearing me. I hope you are jotting down something. Are we still together, please?
Yes, sir.
Yes, sir. We are here, sir.
Okay, good.
Yes, sir.
The next one is parametrics and non-parametric tests. Now, let me just give you this straight. Parametric tests take up assumption. So that means that before you can use parametric tests, you have to check for assumption. Like for instance now, if I want to use a t-test is the parametric test. What is the assumption that I'm going to check under the t-test? Is that number one, my sample size must be less than 30. And then my second assumption is my population variance is unknown. I'm using t-test as an example. I'm using t-test as an what? As an example under parametrics. So parametrics take up assumption. Immediately you put that on your paper that parametrics take up assumption. Parametrics use assumption, e.g., t-test, z-test, chi-square test, f-test. So those are the example under parametric test. Parametric tests make use of assumption. Number two, the next one is non-parametric tests. The non-parametric tests don't use assumption. They are assumption free. They are distribution free. They don't use assumption. They are what? They are distribution free. Let me just put it like that. They are distribution free. Why the parametric test, they are not what? Distribution free. Example of non-parametric tests. Number one is sign test. Sign test, like your sign, plus, minus. Sign test. Another one is what we call the Wilcoxon test. Wilcoxon test is another example of non-parametric test. Another example of non-parametric test is what we call the Mann-Whitney test. Mann-Whitney test. Another example under the non-parametric test is what we call the Kruskal-Wallis test. Kruskal-Wallis test. So once you just remember one, you can just write one or two. Then you move on with the remaining question. So we move to the next one. The next one is differentiate between the what? The type 1 error and type 2 error. We have two errors in statistics. The first error is what we call the type 1 error. And then the second error is what we call the type 2 error. In this particular one, I will just slow it so that you can write it correctly. What is type 1 error? Type 1 error is the error that you commit when you reject the non-hypothesis. Type 1 error is the error that you commit when you reject the non-hypothesis or you reject the true hypothesis when it is true. Let me take it again. Type 1 error is the error that you committed or you commit when you reject the non-hypothesis when it is true. In statistical inference, under the testing of hypothesis, we always have what we call the hypothesis. Under the hypothesis, we have the non-hypothesis and then we have alternative hypothesis. How do you differentiate between the non-hypothesis and alternative hypothesis? In stating your non-hypothesis, the non-hypothesis always go with the negative word, like there is no association. It is not significant. There is no difference. Those are the words of non-hypothesis. So hypothesis goes with those words. Why the alternative hypothesis is other way around. The alternative hypothesis is what is other way around. Alternative hypothesis will tell you that there is association. Alternative hypothesis will tell you that there is difference. Alternative hypothesis will tell you that it is statistically significant. Those are the word of alternative hypothesis. Now, after you've carried out your test, maybe you've performed any of the tests, maybe it's T test or the F test or the Z test. After you've carried out your test, and you now discover that you're supposed to accept your known hypothesis that, oh, after I've carried out this test between the age and the height, that means that there is no association between the age and the height. That's supposed to be your conclusion. But mistakenly, you know what? You now reject that. You now conclude that there is association between the age and then the height. That means that you've committed type 1 error. Let me recap that one again. Let's say, for instance, I want to check the association between the age and the height. The non-hypothesis will be there is no association between the age and the height. That is the non-hypothesis. The alternative hypothesis will not be there is association between the height and the weight. Now, after you perform the test, suppose that your test now confirm that there is no association between the what? Between the height and then the weight. But mistakenly you reject it. Then you now conclude that there is association between the height and the weight. You've committed type 1 error. You've committed type 1 error. Are we still together?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. We are here.
Yes, sir.
Okay. Type 2 error now is when you accept your non-hypothesis when you're supposed to reject it. Let's say, for instance, now, instead of you to reject the non-hypothesis that there is association, after you've rejected the non-hypothesis, you are going to have there is association between height and weight. You now accept it that there's no association between height and weight. So that means that you've committed what we call the type 2 error.
Sorry, come again, sir. Concerning the definition of type 2 error.
For type 2 error, when you accept your non-hypothesis, when you're supposed to reject it. When you accept your what? Your non-hypothesis, when you're supposed to reject it. Type 1 is that when you reject the non-hypothesis, when you're supposed to accept it. Is the other way around. Now, the correction for type 2 error is this is very, very important. For those people in public health, or you are in clinical sciences, or you will be carrying out research relating to health-related issue. The correction of type 2 error is what we call the power test. The correction of type 2 error is what we call the power test. Now, the type 1 error is denoted as alpha, which is called the level of significance. The type 1 error is denoted as what? As alpha, which is called the level of significance. The type 2 error is denoted as beta. And then the correction of type 2 error is what we call the power test, which is equals to 1 minus beta. The correction of type 2 error is what we call the power test, which is equals to 1 minus the beta. Any question on that before we move to binomial and Poisson?
Please come
Can you
again,
come
sir.
again on type 2 error?
Correction.
You said it is known as beta.
The correction.
The correction of type 2 error is 1 minus beta. And it is called power test. Do we get that?
You said type 1 error is denoted by alpha. Type 2 error is denoted by beta.
Yes.
Then the correction of type 2 error is 1 minus beta.
Yes.
Okay.
Which is called what? What is the name of 1 minus beta?
Power test.
Power.
Good. So the next one is differentiate between the binomial distribution and Poisson distribution. We've done this yesterday.
What is the correction of type 1 error?
1 minus
correction
alpha.
of type 1 error is called what?
1 minus alpha.
1 minus alpha.
So by the time you 1 minus alpha, by the time you multiply it, it is called confidence interval. That's why they will ask you to calculate 95% confidence interval. Or confidence limit. Let me put it like that. So binomial is the end trial of Bernoulli distribution. That is, the outcome of binomial is 2. The probability of success and the probability of failure. And then anytime you perform that experiment more than 1, let's say 2, 3, or 4, it is binomial. From the word bi. Bi means 2.
Okay, yes.
Now,
come again, sir, please.
Come again, sir.
We've treated this yesterday. The binomial is the end trial of Bernoulli distribution. That is, the binomial asks for 2 outcomes. We have probability of success, which is denoted as P, and then the probability of failure, which is 1 minus probability of success, which is Q. And then anytime you perform the experiment for binomial, your n must be greater than 1. So that means that you must perform the experiment more than once. So that means that from 2, 3, 4, 5, and so on and so forth. Now, the parameter of binomial is NP. N is the number of times that you perform the experiment, and then the P is the probability of success. Or let me put it like that: N is the sample that you have. Let me put it like that. Let me say number of times you perform the experiment, because your X can be the number of times that you want to check. So your N is the number of observations that you have. Now, the mean of binomial, which is also called the expected value. I told you also yesterday that expected value is the same thing as mean. The mean of binomial, it is what? It is called MP. The mean of binomial, it is what? It is NP. And then the variance of binomial, it is NPQ. Please, can you hear me, please? Someone said I'm breaking up. They can't hear me. Can you hear me?
We are hearing you, but the network is failing.
No.
Where did I stop? So that I can pick it up from there.
The variance of binomial is NPQ.
Good. The variance of binomial is NPQ. So Poisson now. Remember I told us yesterday that Poisson is used to model.
We're not hearing you very well. The voice is breaking.
It's your network.
Remember that I told us yesterday that Poisson is used to model real disease. a rare disease. And then the parameter of Poisson is lambda, which is the expected value of Poisson, which is the average, which is the mean. So if you are hearing the word average, it's still the same thing as mean. It's still the same thing as expected value. Now, the mean and the variance of Poisson distribution is the same. That is, the mean is lambda, and then the variance is also lambda. So the mean is equal to the variance for the Poisson distribution. Are we together?
Can you come again on Poisson distribution?
For Poisson distribution, we normally use Poisson distribution for rare disease. The disease that is not common. Now, the mean of Poisson distribution is called lambda. And then the mean and the variance of Poisson distribution are the same. And when your n, which is the sample size, is very large,
sir? The mean and what?
Mean and variance. The mean and variance. The mean and variance. The mean and variance
is the same.
So when your n, which is the sample size, is large and the probability of success is small, binomial is approximate to Poisson. I've shown us that yesterday. So let's move to the next one. Distinguish clearly between probability and non-probability sampling. The first thing is that probability sampling are scientific method. It's what the origin of probability sampling is based on scientific method. And under probability sampling, we have what we call the simple random sampling. Number one, simple random sampling, SRS. Number two is what we call the stratified random sampling. Stratified random sampling. Number three is what we call the cluster sampling. The cluster sampling. And then number four is what we call the multi-stage sampling. Is what we call what? Multi-stage sampling. Let me take it again. Probability sampling are scientific based. So that means that the root of probability sampling is what is scientific. Now, under the probability sampling, we have simple random sampling. That is number one. Number two, we have stratified random sampling. That is number two. Number three, we have cluster sampling. Number four, we have what we call the multi-stage sampling. If I thought you asked you to distinguish between probability sampling and non probability sampling, immediately you just tabulate and you start putting simple random sampling under probability sampling, all those things that I've mentioned, you still get your mark. Now, for non-probability sampling, they don't base on what? On scientific what? On scientific belief. They base on your own directive, your own belief. Let's say, for instance, now you want to carry out a survey on you want to carry out a research on breast cancer. Let me put it like that. And then, if you want to use the probability sampling, that means that, let's say, for instance, now you want to use one of the probability sampling. That means that you need more sample. And then you discover that it is only you will see a breast cancer patient. I'm just saying that. In that case, any patient that you see that maybe she has breast cancer, you are going to pick it straight. You are not using any scientific. Your own discretion is that any patient that I see, I'm picking it straight because I don't have enough sample. In that case, your sampling techniques or your sampling method. There's difference between the sample size, sampling method, and sampling techniques. So your techniques that you use is your own techniques, not scientific techniques. Now, in that case, we now have what we call non-probabilistic sampling. Example is what we call the quota sampling. Let's say, for instance, now, for those in UI, if they want to admit undergraduate, there is a particular percentage, they call it quota, that they normally give to northern, the northern area. So that means that if you are from south, if the cutoff mark is 65%, those that is coming from north, they may say 60% or 69.5% because they are less privileged in terms of education. So that particular method that the UI is using for the sampling is called the quota sampling. It is non-probabilistic sampling. Are we together, please?
Yes, sir.
Another example of non-probability sampling is what we call the judgmental sampling. Judgmental what? Judgmental sampling. So that is for that under this question 2. So let me welcome question before we move to the question 3. Any question, please?
Hello, sir.
I'm with you.
Hello, sir.
I'm with you.
Yes, under the question E, where you are explaining the parametric, you mentioned that the examples we can use there is t-test, z-test, and f-test. And you said that number 1, you say my sample size must be less than 30. The second example you gave, I didn't hear you. Number 1 is that my sample size must be less than 30. So the second one, I didn't hear
Number
you.
2, the second assumption is that your variance, your population variance, which we call sigma. Remember from the formula that I gave under the population variance is sigma, the sigma square rather. Your population variance, which is the sigma square, is unknown. That means that you are not given. It is what? It is unknown.
It is unknown. Thank you, sir.
Yes. Any other question? Please ask your question now. If you don't get any part from that A to H, please ask, because you are going to write something about that. Who knows? Maybe it's going to give you back like this. So ask your question now.
Hello, sir.
I'm with you, madam.
Thank you, sir, for that beautiful explanation and everything. I just want to maybe find out, because I've seen simple random sampling, stratified clustering, cluster sampling, multi-stage, and I think maybe systematic. Is it not part of it? Systematic sampling something.
Yes, systematic
Thank you,
sampling is
sir.
part of it. It's part of probability sampling. Yes, it's part of them. Good. The systematic sampling is part of them. Any other question? Please, this number 3 question, can you see it, please?
There's nothing in
I
number
can't find the
3.
question here.
There's no number 3 here.
Oh, sorry.
That number 4 is our number 3.
Okay, ma.
I'm trying to check the question that she sent to me. I think the mistake is from the numbering from the lecturer rather. So 3, they move to 4. Okay, that number 4. That number 4. Then let me take it from there. I don't know how we're going to do it tonight. You will need the knowledge of statistical inference. Now, let's look at it. I don't know, maybe you have the knowledge of statistical inference before, but let's look at it. According to data from the US Center for Health Statistics, Americans aged 18 to 24 made an annual average of 3.9 visits to physician. Someone sent me a message. Okay, Rashidat, you are raising up your hand. Do you have a question for us?
Oh, sorry, it was a mistake, actually.
Okay.
Thank you, sir.
Okay, ma'am. So, Statistical Abstract of the United States, 1998. Last year, a random sample of 350 Americans in this age group, showing a mean of 3.7 visits per person, with a standard deviation of 1.6 visits. Test at the 5% level of 5% significant level, whether the mean number of visited to physician last year by American in this age group differ from 3.9. Okay. I don't know. Can you permit me to take you to testing of hypothesis? Because if I'm explaining this now, you may not get it if you don't understand some concepts.
Okay, sir. Let's go.
Go ahead.
All right, thank you. Please, by the time I explain the concept, you will see that you'll be the one to solve this question. So let's see. Let me minimize this so that I can. Can you see my screen?
Yes, sir.
Yes, sir.
Yes, yes.
Okay.
Nothing is showing on your screen.
It's your network. Yeah.
It's your network.
So now I've explained the concept of hypothesis for you, the non-hypothesis and alternative hypothesis. That's what you are seeing here. So, but under the concept of alternative hypothesis is either we have one directional or we have two directional. What did I mean by that? If I say there is no difference between, please let's mute our mic. This is very, very important. If I say there is no difference between my age and my height, that means that my age is equal to my height. If I say there is no difference between my age and my height, so that means that my age is equal to my height. Now, the alternative hypothesis will now say there is difference. Alternative hypothesis will now say there is difference. Now, if there is difference, is it that my age is greater than my height, or my height is greater than my age? But we don't know. But we know that that is the two ways that we can move. If the non-hypothesis is telling me that there is no difference between my age and my height, an alternative hypothesis is telling me that there is difference between my age and my height. So that means that is either my age is greater than my height, or my height is greater than my age. Or is either my age is greater than my height, or my age is less than my height. One of the two. So in that case, we only have that two options to move. Is either my age is greater than my height, or my age is less than my height. So in that case, we'll all normally call it two-tailed test. I don't know, maybe you've heard about two-tailed test, one-tailed test. That is what we call the two-tailed test, because we have two ways to move. It's either the age is greater than the height, or the age is less than the height. That's what we call the two-tailed test. But let's assume that from the question, they've stated it that assuming that your height is greater than your age, the non-hypothesis always go with there is no, there is no, there is no. So that means that your height is still equals to your what? Your weight. That is for the non-hypothesis. Then your alternative hypothesis, since they've said that assume that the age is greater than the height. So that means that they've specified. You don't need to be thinking that is the age greater than the height or the age is less than the height. They've specified already that the age is greater than the height. So in that case, you only move in one direction. So that means that you have one tail test.
Tail test.
So you must know the difference between two tail test and one tail test. That is for that. Now, this is how we normally look at this example that I cited here.
That's the end.
Let's mute our mic. So if you look at this example that I cited here, you want to test if a new drug is more effective than the existing one. More effective than the existing one. From the knowledge of what I just explained now, is this a one-tail test or two-tail test?
Two-tail test.
Okay.
Two-tail.
Okay. Now, look at that question. More effective than, that means that the existing drug, the level of effectiveness of existing, the new drug is greater than the existing drug. Read that question again. You want to test if a new drug is more effective than the existing drug. That means that your non-hypothesis is what? The new drug is no more effective than the existing drug. The alternative will be the new drug is more effective than the existing drug. So in that case, we know what we want to test for. This one is one-tail test, not two-tail. Because we are moving in the one direction of greater than. The new drug effectiveness is greater than the existing one. Let's look at the second example that I have here. Now, a two-tail test is used when you are taking whether the parameter is different from either greater than or less than, without specifying the direction. Now, let's say, for instance, now, the new drug has no effect on malaria patients. That is the non-hypothesis. Now, the alternative hypothesis is now what? Let's look at this. If I say your power has no effective, that means that your power is zero. Okay, this one is still explaining what? The non-hypothesis. Now, the alternative hypothesis is now what? The new drug has effect on malaria patients. That's what? Has effect on malaria patients. This one does not specify whether the new drug has more effects, but they just tell us that it has what? Effect on malaria. So in this case, it is two-tail test. You have to be able to differentiate between your test, whether it is two-tail test on one-tail test. Any question on this before we continue?
Sir,
It's not still clear.
can you, yeah, sir, can you go over the difference between the two-tailed test and one-tailed test? Hello, sir.
When we are talking about, let's mute our mic.
Okay.
Ms. Oluwadare, please mute your mic.
Hello, Grandma.
As I was trying to
Yes, we
mute
are
this
glad to you.
particular person, sorry,
Ami.
please, I will have
Just
no choice than to remove him from the call. Okay, so when we're talking about the two-tail test, either two-tail test or one-tail test, the non-hypothesis is the same. It is the non-hypothesis is the same. There is no association. There is no difference. Not statistically significant. The non-hypothesis is what? Is the same. It is only the alternative hypothesis that changes. It is only the alternative hypothesis that changes. Alternative hypothesis will determine whether your test is one tail or two tail. Alternative hypothesis will determine whether your test is one tail or two tail. How do you know whether your test is one tail or two tails? Immediately you read your question, and there is no place whereby they mention it that your test is more, the original drug is more than the existing drug, or your weight is higher than your height, or your weight is less than your height. If they did not mention those statements, that means that you are dealing with two-tail test. That means that your alternative hypothesis is just what? There is no effective. Sorry, there is effective. That's your alternative hypothesis. But the non-hypothesis is there is no effective. The alternative hypothesis is there is effective. In that case, it is called a two-tail test. But immediately they mention it from your question that the effectiveness is more than, let's say for instance now, there is no difference between group A and group B. The alternative will be there is difference between group A and group B. But let's say for instance that they now mention that the group A is higher than group B. So that means that in that case, it is one sample, sorry, it is one tail test. It is one tail test. But if the question did not specify that group A is higher than group B, so that means that if group A is not equal to group B, that is for non-hypothesis. The alternative hypothesis will be group A is equals to group B. So in that case, it is two-tail test. Are we clear with the one tail and two-tail test?
Yes, sir.
Okay. Let me now test your knowledge now. You say you are clear. Let us now go back to our question. So I'm
Hello,
going to
sir.
start from there.
Hello,
Yes.
sir.
I'm with you. Go ahead.
Concerning this one-tail test and two-tail test, there was a time somebody was explaining this thing to me, a lecturer. And you know that time they said we must buy one booklet like this, tables full of tables in it. So the person we calculated the question, I've forgotten entirely, but I could remember that we bought that and inside it there were these figures and tables, something like 4-figure tables of those days. So we now compared what we calculated against that one total, because I did not even understand it. So I don't know, maybe when we meet for the physical class, maybe you can then put more light on it, because with this calculation, maybe I let me say Sakwe, maybe I I'm not getting it, sha.
Okay.
Thank
What
you,
you
sir.
just mentioned now is your decision making.
Ah,
How to make decision whether to reject the non-hypothesis. Please let's mute our mic. What you just mentioned now is how to make decision whether to reject the non-hypothesis or to accept the non-hypothesis. Traditional method we normally use once you calculate your test. Let's say you are using test.
I can't hear you
No more
again.
voice. No sound, sir.
Is the network?
Sound, no screen. No sound, no screen, please, sir.
Same here, ma.
Okay, I'm back. Sorry, the network So I'm back. So what I'm trying to say here is that uh in that case, we normally use the calculated value that we've calculated. We normally compare with what? With the tabulated value that we call table value. So by the time we do that, then we reject our non-hypothesis if the calculated value is greater than the tabulated value. Otherwise, we do not reject the non-hypothesis. But that was traditional method. In the modern day method, we make use of what we call the p-value, the probability value. We compare the probability value with the alpha value. So by the time your probability value is less than the level of significance, which is alpha, we normally take alpha to be 0.05. By the time the level of the p-value is less than the alpha, then we reject the non-hypothesis. That is how we
Your
normally
screen
make
is not
decisions.
showing.
You are
I've
not
not shared
seeing
any
the
screen.
screen, sir. Okay, sir.
I've not shared any screen.
All right, sir.
So in that case, that means that you are maybe you are rejecting the non-hypothesis or you are accepting the non-hypothesis. So before we move to that question, I'm going to give us 5 steps that you need to follow if you want to carry out your test of hypothesis. 5 steps that you need to follow if you want to carry out your test of hypothesis. Now, number 1 is can you see the screen now?
Yes, sir.
Okay. What can you see? What can you see? Let me confirm.
State the null
State the null
hypothesis.
hypothesis.
Hypothesis, testing
State
of
the
hypothesis.
alternative hypothesis.
Okay, good.
Steps to
Now the
hypothesis
first
testing.
one, the number one thing you have to do is you are going to state your non-hypothesis.
Hypothesis.
Once you state your non-hypothesis, the non-hypothesis is called the H naught or H0. Then the alternative hypothesis is called the H1.
Which one?
Then followed by you are going to state the level of significance, which is alpha. We normally take it to be 0.05. Now, the next one is choose the appropriate test statistic. What type of test do you want to use? Is it the Z test? Is it the F test? Is it the chi-square test? Then evaluate the test statistics. Then the last one that I mentioned now, then you decision making. That is when you are going to be using, if the calculated value is greater than the tabulated value, you reject the non-hypothesis. Or if your p-value is less than the alpha value, you reject the non-hypothesis. That is the last stage of testing of hypothesis, of carry out your test. Now, let me give you criteria for selecting test. Please write it down. It's very, very important. Are we together?
No, sir. What do you say we should write down?
Criteria for selecting
I want
test.
to give you test. What are the things that you have to look for in your question so that you can know that this type of this question belongs to, I'm going to use this type of test. Number one test that I'm going to be talking about is what we call the Z test. Z for zebra. Z test. How do you know whether your test, your question will follow a Z test? There is two criteria that we normally check, but Z tests have to satisfy just one out of the two. If one is satisfied, then you are going to use Z test. Number one is this. Your sample size must be large. That is, your N must be greater than or equals to 30. If you can see my screen, this is what I mean by the large sample size. Your N must be greater than or equals to 30. That is what we call the large sample size. That is number one. Number two for selecting Z test is that your population variance must know or given from the question. That is this number two that you are seeing here. Number one is that the sample size must be large. That is, your N must be greater than or equals to 30. Number two is that your population variance must know or given from the question. That's the two criteria for selecting Z test. But
Must do what, sir?
once Z satisfies, what did you say?
Hello, sir. Criteria for what, sir?
For selecting
The
Z
two
test.
Selecting Z test.
Okay, sir.
For selecting Z test. So, number one is that your sample size must be large, greater than or equals to 30. Then the second one is your what? Your population variance must be known or given. So Z have to satisfy one out of these two. It does not mean that you have to satisfy the two before you can use it. Once you check your question and you discover that one out of these two is satisfied, then please mute your mic. I'm trying to mute you and you are still unmuting yourself. Okay. So once any of these two is satisfied, you can use your Z test. That is the criteria for selecting Z test. Another test is what we call the t-test. What is the criteria for selecting t-test? Number one, the sample size must be small. That is, your n must strictly less than 30. And then number two is that the population variance is unknown. In that case, you can use t-test. Please note that it is necessary for t to meet up these two criteria. T must meet up these two criteria. T must meet up with these two criteria. Because once one is violated, you go back to Z. Let's say, for instance, now your your sample size is large here. That means that you use Z test, not T, because Z have to satisfy one out of this. So let me quickly move to our question. Then you are going to tell me two things in our question. Number one thing that you are going to tell me,
Hello, sir.
the.
Hello, sir.
Go ahead.
Hello, sir.
I can hear you. Please go ahead with your question.
I'm sorry. I think you are going to ask for questions before you move on to another one. That's the reason why I've not asked my question. Like the 5 steps to carry out hypothesis, I got maybe only 2 or 3. I got state the null hypothesis, then choose the appropriate test, then decision making. So I missed 2. Thank you, sir.
You state your null hypothesis. You state your alternative hypothesis. You state your level of significance alpha, which is 0.05. You choose the test statistics for your question, and then you make decision. Did you get that, please?
Thank you, sir.
Any other question again? Okay. So let me share the question again.
Sir, a complete version of the question is now on your page. There is question 3 there. So that we
Okay.
don't omit any. Yes, sir. So sorry.
Okay, let me quickly go to that WhatsApp and check.
Sotiri is not here.
It's there. We will all see it now.
Okay, I think we have question 3 now. So let me. Can you see my screen now?
Yes, sir.
Okay.
Hello.
Let's mute our mic.
It's gone, oh. The screen has gone.
Yes.
What about now?
Back now.
Yes, it's back. It's back. Thank you.
So now, look at the number 3 question. The diastolic blood pressure of the student of the student of the assumed normal distribution with standard deviation of 14 millimeter mercury. A physician is taking a sample of simple random sample of 12 from this population and determine the mean diastolic blood pressure is what's it called, 69 millimeter mercury. Can the physician conclude that at alpha level of 0.5 that the mean diastolic blood pressure is larger than 90? Can we see this question, please?
Yes, sir.
Yes, sir.
Okay, from the knowledge that you've gained tonight, what will be our non-hypothesis? Let me start from there so that we know that whether we know it or not. What will be our non-hypothesis? Let me start with that. Because that's the first thing that you have to state in carry out your test. What will be our non-hypothesis?
The mean diastolic blood pressure is not larger than 90 millimeter mercury.
Good. Good. Great. What will be the alternative hypothesis?
That the mean diastolic blood pressure is larger than 90 millimeter mercury.
It's larger than 90 millimeter mercury. What type of test? Is it a one-tail test or two-tail test now?
One tail.
One tail.
One tail, because it is larger than. So can you see that you are getting it now? Let's mute our mic. Now, the second thing that I want to ask now is that based on the knowledge of the Z test for choosing Z test and T test, what type of test we are going to use for this question?
Z test.
Z test.
Why?
Z test.
Because
it is
larger
more than
30.
Which one is more than 30?
It's not up to 30.
Our sample is
12.
12.
12.
T-test
30.
is less than 30.
It's T-test. T-test because the sample test is less than 30. This is 12. That is T-test that we are going to use.
We are
So
using
it's
T-test.
T-test.
Okay. Can we mute our mic now? Please note this. Anytime you are hearing the word, it is normally distributed. Please take note of this word. Let me even bold it for you. Let me bold this particular statement. Anytime you hear assume normal distribution, so that means that the variance that they use in computing this standard deviation is population mean, is population variance. Anytime you are hearing, anytime you are reading the question, and the question, in that question, you are reading assume normal distribution, so that means that the variance of that particular question is a population variance. Because of this statement, assume normal distribution. So in this case, since the population variance is known, we assume it because according to their question, this particular test is a Z test because it satisfies the one criteria. It satisfies out of the two criteria, it satisfies one, which means that the population variance is known. Did you get this, please?
Please come again, sir.
Did you see the statement that I bolded?
12.
Anytime you are seeing this statement, you assume that you are working with population. So that means that the value given here, the standard deviation that you are having here, if you want to get the variance, it's going to be what? 14 squared. So you are going to get the variance. So now the standard deviation that you are having here is gotten from the what? The population variance. because they ask you to assume normal distribution. Anytime you are hearing the word assume normal distribution, they work with population. Do we get that, please?
Yes, sir.
Okay. So what type of test we are going to use now?
Z test.
We are going to use
Z test.
Z
Z
test. We are going to use what? We are going to do what? We are going to
Use Z
use
test.
Z test. So, any question so far? Class rep, are you there?
Hello, sir.
I'm still there.
So when is our next class?
Next week, Monday.
Okay, before that, at least I should be able to solve, if not everything, I should be able to, please let's mute our mic. If not everything, because of time frame, because I still have other things I'm also doing. So if not everything, I should be able to solve at least 7 out of this 15 questions and send it to you so that you can send it to the group so that it will prepare them ahead of Monday. So coming on Monday, I'll just come to explain it. I think that one will help us a lot.
Okay, sir. Thank you, sir.
It's better than
I think that one will help us. Do we all agree with that? Do we agree with that, please?
Yes, sir. Thank you, sir.
Okay. So, Madam Adijat, you are raising up your hand. So let me welcome 2-3 questions, then we'll call it a night at this point. Okay, Madam Adijat, ask your question.
Hello, sir. I don't have any question. No, I just mistakenly raised my hand.
Okay, please put your hands down. Then Elizabeth.
Yes, sir. Please, sir, it doesn't mean that whenever we see normal distribution, we are going to use Z test.
Anytime you are seeing a normal distribution, please mute your mic. Anytime you are seeing a normal distribution and they ask you to carry out a test, it is Z test. Okay, it's very, very important. Note that. Any other question?
Hello, sir.
Go ahead with your question, ma'am.
Yes, sir. So does it mean that we are going to use the formula for Z test to calculate this particular number 3?
Yes.
Okay.
We are using the formula for Z test.
Thank you, sir.
Any other question? So in the absence of none, I'm going to, once this link is ready, I'm going to send it to class rep. So she will send it to the group so that you can check it. So before Monday, I will send you the solution, at least 7. So that means that I can send more than 7, but at least 7. So I'm using probability terms now. So
thank you, sir.
In the essence of that, please enjoy your night. Have a good rest and see you on Monday. Thank you.
Thank you.
Thank
you very much.
you, sir. God bless you.
Good night, sir.
Thank you, sir.
Thank you very much, sir.